Hey everyone, welcome back to BigBrains Tip. Today we are solving daily temperatures, a medium level interview problem. The basic solution is easy, but getting it down to O of n requires a really useful pattern called a monotonic stack. Let's see how. We are given the temperature for each day. For every day we need to find how many days we have to wait until we get a warmer temperature. If there is no warmer temperature in the future, we put 0. For example, 73 becomes 74 the very next day. So its answer is 1. But for 75, we have to wait until 76, which is 4 days later. The obvious solution is to take every temperature and look at the temperature after it until we find a warmer one. So for 75, we will check 71, then 69, then 72, and finally we find 76. We do the same thing for every single day. In the worst case, we are repeatedly scanning the array, which gives us O of n square time. So the question is, can we avoid checking the same temperatures again and again? Let's think about what happens as we move from left to right. Some temperatures don't have an answer yet. For example, after seeing 75, 71 and 69, all three are still waiting for a warmer temperature. So instead of searching forward again and again, why don't we simply remember these unresolved days? And whenever a warmer temperature arrives, we can use it to resolve the temperatures that we're waiting. A stack is perfect for this because we only need to deal with the most recently unresolved temperature first. We'll store the indices of these temperature in the stack. Then, whenever a warmer temperature comes along, we'll check the top of the stack. If the current temperature is warmer, we have found the answer for the day. Let's go through the example. We start with 73. We haven't seen anything warmer yet, so we put its index into the stack. Now we see 74. 74 is warmer than the temperature at the top of our stack, which is 73. So we have found the answer for 73. 73 had to wait 1 day. We remove it from the stack and store 1 as its answer. Then we put 74 into the stack because 74 is now waiting for its own warmer day. Next comes 75. Again, 75 is warmer than the top of the stack, which is 74. So we resolve 74. It also waited 1 day. Then we push 75 into the stack. Now we get 71. 71 is not warmer than 75. So we can't resolve 75. We simply put 71 into the stack. Then we get 69. 69 is also not warmer than 71. So we put it into the stack. Now we have 3 temperatures waiting for something warmer. Now we get 72. This is where the stack becomes really useful. We look at the top, 69. 72 is warmer than 69. So we now know exactly what happens to day 5. We pop 69 and store 1. Now the new top is 71. 72 is also warmer than 71. So we resolve that one too. Day 4 has to wait 2 days. But now we reach 75. 72 is not warmer than 75. So we stop. 75 still needs to wait and we push 72 into the stack. Now 76 arrives. 76 is warmer than 72, so we can resolve 72. But we check again, 76 is also warmer than 75. So we resolve 75 as well. And after processing the final 73, nothing is warmer than 76. So those unresolved values simply remain 0. So now the entire algorithm can be reduced to one simple idea. For every temperature, we look at the top of the stack. If the current temperature is warmer, we pop the previous day and calculate how many days it waited. We keep doing that while the current temperature is warmer. Once it isn't warmer anymore, we push the current day's index into the stack. Now we can start solving the problem. So I can have a result array with initial values just 0 and it is of length of the temperature. Temperatures. Yep. And then I can have an empty stack. And now I'm going to be using a for loop for I command and say temp and enumerate. I'll be just getting the index value and the actual value in the list. So I'm just using enumerate temperature And now I'm gonna be checking if the stack is not being empty, and also if the temperatures of stack minus 1. That means if the stack top value, as long as it remains to be lesser than the current temperature, we'll be just having a variable set prev with the top value being popped out, and then we'll be assigning the result array with the position of previous and allocating it with the number of days it has been waiting for. So I minus pre. So previous will be holding the index position, and I minus the previous one will be giving the exact number of days it has been waiting for. So, and now after this I can just append the current temperature index, and at last I can simply return the result. Let's see if it works. Oops, we're having another. All right, good, perfect. The main thing to remember from daily temperature is the monotonic stack pattern. Keep unresolved elements in the stack, and when a new element can resolve them, pop them and calculate the answer. And that's GIP for don't memorize TSA, recognize it.